OpenWebUI is a web interface for interacting with local and remote AI models. It gives users a familiar chat-based workspace where they can ask questions, compare models, manage conversations, upload supporting material, and organize AI-assisted workflows. In a home lab, small team, or private AI environment, it often becomes the visible layer that turns model infrastructure into something people can actually use. It is important to separate the web interface from the model runtime. A runtime loads and serves models. A web UI provides the user-facing experience, accounts, conversations, settings, prompts, document workflows, model selection, and administration. OpenWebUI may connect to local inference services, remote APIs, or OpenAI-compatible endpoints at a high level, but it is not the model itself. A web UI adds usability and workflow structure, but it also adds administration concerns. Conversations may be stored. Uploaded files may become part of knowledge workflows. Users may have different permissions. Endpoint credentials may be configured in the application. Logs, backups, and browser access can all carry sensitive information. A chat interface feels simple, but it sits on top of real systems and real data. Avoid the assumption that local automatically means secure. A local or private AI stack can improve privacy compared with sending everything to a public service, but only if access is controlled, deployment choices are deliberate, and data handling is understood. OpenWebUI is most useful when it is treated as a manageable AI workspace, not just a convenient front end. A typical OpenWebUI deployment includes a browser client, the OpenWebUI application, backend database and configuration storage, one or more model runtimes or inference APIs, logs, uploaded files, user accounts, and sometimes a reverse proxy. The browser is where the user interacts. The application manages the workspace. The model backend performs inference. Each layer has its own operational and security responsibilities. Prompts and responses move through several places. A user writes a prompt in the browser. The application may add system instructions, conversation history, selected model settings, or retrieve document context. The request is then sent to a configured model endpoint. The response returns through the application and is displayed to the user, often with conversation state stored for later use. Storage matters because OpenWebUI can preserve configuration, users, conversations, uploaded content, knowledge collections, and application state. Logs may capture operational events or errors. Backups may preserve the database and files. If storage is ephemeral, upgrades or restarts can lose state. If storage is persistent, it must be protected because it may contain sensitive prompts, outputs, files, and endpoint details. Architecture clarity helps operators troubleshoot and secure the system. They should know where accounts are stored, how model endpoints are configured, where files live, what data is logged, what is backed up, and whether access is local, LAN-based, or remote. A clean mental model prevents the interface from hiding important infrastructure choices. OpenWebUI can be deployed on a local workstation, a home lab server, or a shared internal system. A workstation deployment is useful for personal experimentation and quick learning. A home lab server can provide a more stable, always-on workspace for private AI services. A shared deployment can support multiple users, but it requires more attention to accounts, permissions, storage, backups, updates, and exposure control. Container-based deployment is common at a high level because it helps package the application and its dependencies. Containers do not remove the need for planning. Persistent volumes, environment variables, network bindings, ports, credentials, reverse proxies, and update processes still need deliberate choices. A container that starts successfully is not automatically a durable or secure deployment. Persistent storage should be planned from the beginning. Decide what needs to survive restarts and upgrades, application configuration, user records, conversations, uploaded files, knowledge data, and model connection settings. Backups should focus on the data that is hard to recreate. If the deployment supports important workflows, test recovery before you need it. Installation choices should match privacy, reliability, and maintenance goals. A single-user lab can be simpler and more permissive than a multi-user environment. A private team deployment may need stronger authentication, documented endpoint approval, and scheduled updates. The best setup is not the fanciest one. It is the one that operators can maintain, protect, and recover. OpenWebUI becomes useful when it is connected to model backends. Those backends may be local inference services, remote APIs, or OpenAI-compatible endpoints at a high level. The connection usually depends on an endpoint address, supported API shape, authentication details, available model names, network reachability, and settings such as context length or generation parameters. Model selection should be tied to use case. A lightweight local model may be fine for casual drafting, while document analysis, code help, or structured extraction may need a different model. Temperature and sampling settings influence how deterministic or varied responses feel. Context length affects how much conversation and supporting material can be considered, but larger context can increase resource use and latency. Connectivity testing should be basic and repeatable. Confirm that the endpoint is reachable from the OpenWebUI host, that credentials are valid, that the expected models appear, and that a simple prompt returns a response. Failed connections may come from network binding, firewall rules, incorrect base URLs, unavailable runtimes, invalid keys, missing models, or incompatible API behavior. Document approved models and endpoints. Operators should know which endpoints are local, which are remote, which use private data, which are experimental, and which are appropriate for specific workflows. Documentation reduces confusion when models are renamed, moved, upgraded, or retired. It also helps users avoid sending sensitive work to the wrong backend. Access control starts with account creation and administrative roles. A personal deployment may have one trusted user. A team deployment may need separate accounts, administrative permissions, and clear expectations for who can configure models, manage users, upload documents, or view shared resources. The more people who use the system, the more important it is to avoid shared accounts and informal access. Authentication considerations depend on how the service is exposed. A local-only deployment has a smaller attack surface than a service reachable across a LAN or the Internet. LAN access can still be sensitive in shared networks. Remote access introduces more risk and should be deliberately designed with authentication, TLS at a high level, reverse proxy configuration, logging, and update discipline. Reverse proxies can help centralize TLS, hostnames, routing, and access policy, but they can also create accidental exposure if misconfigured. Operators should know which interfaces OpenWebUI binds to, which ports are reachable, and what network paths exist from users to the service. A private AI workspace should not become public infrastructure by accident. Least privilege applies to both users and connected services. Not every user needs administrative access. Not every workflow needs every model or endpoint. Applications and users should receive only the access needed for their role. Controlled exposure protects prompts, uploaded files, compute resources, endpoint credentials, and the operational integrity of the deployment. OpenWebUI can support document and knowledge workflows where uploaded material is used as context for model responses. At a high level, retrieval-augmented generation involves indexing or retrieving relevant content and placing it into the model's context. Embeddings help represent text for similarity search. This can make private documents more usable, but it also creates new data handling responsibilities. Document sensitivity should be considered before upload. Files may contain personal information, client data, business plans, credentials, internal procedures, regulated content, or proprietary research. Once uploaded, they may be stored, indexed, backed up, searched, or reused in conversations. Treat document features as part of a data management system, not just a convenience button. Source organization improves retrieval quality and review. Knowledge collections should have clear names, purpose, ownership, and freshness expectations. Stale documents can produce outdated answers. Inaccurate retrieval can surface irrelevant or conflicting material. Retrieved content should be treated as evidence for the model to use, not unquestioned truth. Retention and cleanup matter. Decide how long uploaded documents should remain, who can access them, how they are removed, and whether backups preserve them after deletion. For important workflows, users should be able to trace an answer back to source material and understand whether the source is current. Retrieval is most valuable when it remains auditable. OpenWebUI can support reusable prompts, system prompts, task-specific assistance, conversation history, and workspace organization. These features help teams turn repeated work into more consistent workflows. A reusable prompt can standardize instructions for summarization, drafting, review, classification, or analysis. A task-specific assistant can combine a model choice, instructions, and expected style. Prompt templates should be clear, maintainable, and reviewable. They should explain the task, constraints, output expectations, and any source handling rules. Vague prompts may work once but fail under different inputs. Prompts used by a team should be treated as operational artifacts that can be versioned, improved, and reviewed. Conversation history can improve continuity, but it can also mix contexts in confusing ways. A conversation about personal tasks should not become the basis for client work. Experimental prompts should not silently shape production workflows. Separating personal, client, experimental, and production workspaces reduces accidental data mixing and inappropriate reuse of context. Good workflow design is practical. Decide which prompts are reusable, which conversations are disposable, which files belong to which collections, and which model should be used for which task. The goal is to make AI assistance more reliable and less ad hoc. A well-organized workspace helps users understand what the assistant is doing and why. Privacy and security in OpenWebUI begin with recognizing what the system may hold: prompts, outputs, uploaded files, conversation history, user accounts, API keys, endpoint configuration, logs, database backups, and operational metadata. Any of these may contain sensitive information. A private AI interface is still an application that needs secure operation. API keys and endpoint credentials should be protected because they may allow access to model services, billing resources, private endpoints, or internal systems. Avoid exposing credentials in screenshots, shared notes, logs, or configuration files with broad access. Rotate credentials when needed and remove old keys when endpoints are retired. Plugin and tool features should be approached carefully at a high level. Anything that lets a model interact with external systems, files, APIs, or automation increases the need for permission boundaries and review. Model output should not be treated as authority to perform high-impact actions. Keep tool use scoped, monitored, and appropriate to the deployment's purpose. Operations include updates, monitoring, backups, and incident response. Watch resource usage, disk growth, failed requests, unusual access, and model endpoint errors. Keep the application and supporting components updated with a deliberate process. If accidental exposure or misconfiguration occurs, operators should know how to disable access, preserve evidence, rotate credentials, restore from backup, and notify the right stakeholders. OpenWebUI can make local and private AI workflows easier to use, organize, and administer. It provides the user-facing layer for chat, prompts, model selection, document workflows, and shared workspaces. It can connect to local runtimes, private model services, or remote APIs, but the interface is only one layer in a broader AI system. Strong use starts with clear deployment choices. Decide whether the system is personal, home lab-based, or shared. Plain persistent storage, backups, updates, account management, model endpoints, and network exposure. Document which models and endpoints are approved for which workflows. Keep installation choices aligned with privacy, reliability, and maintenance goals. Document and prompt workflows need care. Uploaded files may be sensitive, retrieval can be stale or incomplete, and conversation history can mix contexts. Reusable prompts and workspaces are powerful when they are clear, maintainable, and separated by purpose. Treat retrieved content as evidence, not automatic truth, and preserve source awareness where possible. The goal is not only to get a chat interface running. The goal is to build a manageable AI workspace that supports useful workflows without creating unnecessary data exposure or administrative risk. With controlled access, privacy-aware document handling, protected credentials, backups, monitoring, and operational review, OpenWebUI can be a practical foundation for private AI work.